Hi, welcome everybody. In this tutorial, we're going to learn how to do a 2D axisymmetric analysis of a pressurized cylinder. So the first step for this example, I'm going to grab the static structural analysis icon and drag it over to the green box. And then we're going to add a material. So I'm going to right click, edit, and then I'm going to right click here where it says click here to add new material, and then left click engineering data sources. And then you can see here that there's a few different libraries that you can choose from that ANSYS provides for you. So I'll click on general materials, and then I'm going to go over here and click the plus sign to add aluminum alloy. Now the next step for our 2D analysis is to tell ANSYS that we're doing the analysis type in 2D. So if you click on geometry and you come over here to analysis type, change that to 2D. Now we're going to create our geometry. So I'm going to right click on geometry and then left click new design model or geometry. Now the first thing I'm going to do is change the units to inches. Now we're going to create our 2D geometry. So in ANSYS, in order to run a 2D axisymmetric analysis, you have to sketch your geometry on the XY plane. So I'm going to click on the XY plane and then click on the normal Z vector. Now, in ANSYS, in order to run or the 2D axisymmetric analysis, the radial axis is the x-axis, and the axial direction is the y-axis. So the y-axis represents the axis of revolution for the part. So for our cylinder, I'm going to go here and click Sketch, and I'm going to click on Rectangle, and I'm going to sketch just a generic rectangle here by left-clicking once and then dragging and then left-clicking again. Now we're going to dimension it. So I'm going to go here to Dimensions and leave it under General. And then I'll click on the top of the rectangle. And I'm going to set that dimension to 1 inch. And then I'm going to click on the right side of the rectangle and set the V2 dimension here to 10 inches. Next, I'm going to align the bottom of the rectangle so that the bottom edge is coincident with the x-axis. So at y equals 0. So I'm going to click on the bottom edge and then the x-axis, and you'll see that it will now be coincident. And then I'm going to dimension the distance from the y-axis to the left side of the rectangle, which will represent our inner radius of the cylinder. So I'm going to go back to Dimensions and then click on Horizontal. and click the left edge of the rectangle and the y-axis. And I'm going to set that to 5. And the next thing, or the final thing I'll do is we'll create the surface. So I'll left click on modeling and then go here to concept and then click on surfaces from sketches. And then where it says base objects, I'll expand the drop down or the tab here for XY plane and then left click on sketch and left click on apply. And then I'll left click on generate. And there we have our cross section for our cylinder. So I'm going to click save. And now I'm going to go back to the ANSYS main menu and we'll left click on model and then right click and then left click edit. And I'm just going to make sure the units are in inches, and they are. Now I'm just going to expand the global coordinate or the coordinate systems and click on the global coordinate system just to verify our geometry is where we intend it to be. And it is. Now I'm going to left click on the tab for under geometry and left click on geometry. And then under here, under this window or box, you'll see it says 2D behavior. I'm going to change that to Axisymmetric. And then to assign the material properties, if you left click on the surface body, and then under here, under material assignment, if you click on that, you'll see an arrow here, left click, and then you can choose your material. For this case, I'm using aluminum alloy, so I'll left click on aluminum alloy. And the next thing I'm going to do is I'm going to set up the mesh. So I'll right click on mesh, insert sizing, and then up here you can click on faces and then left click on the surface body. And under this yellow box here, left click apply. And then I'm going to change the element size to 0.125 inches. And then I'm going to left click on mesh and change the element order to quadratic. And then right click on mesh and then left click generate mesh. And then you'll see the mesh has been generated. Now I'm going to set up the boundary condition. So I'm going to left click on static structural and then right click insert. And I'll set up a displacement boundary condition. So I'm going to click on the very bottom edge of the rectangle. So I'm going to click here first to edge, and then left click the bottom of the rectangle and click apply. And I'm going to set the y component displacement equal to 0. And then the next thing I'm going to do is add the pressure load. So I'm going to, again, I'll right click on static structural, insert, and then click on pressure. left click on pressure. And then I'm going to select the inner or the left edge of the rectangle, which represents the inner part of the cylinder. And then left click apply. And let's say we'll run 1,000 psi pressure. So I'll type in 1,000 and click enter. Now I'm going to set up our post-processing stress results. So I'm going to left click on solution and then right click, insert stress. We'll look at our equivalent stress, our maximum principal, and then we will look at our normal stress in the x direction, which is will be the radial stress for this case. Our normal stress in the y direction, which is the axial stress, which should be 0. And then finally, I'll add one more normal stress, and we'll look at the hoop stress, represented by the z-axis. And then I'll go here and left click on solution and right click solve. All right, and sometimes it helps I like to align the geometry so that it kind of lines up with x being the radial direction. Being up and down in the window, and y, the axial, being left and right. Yeah, we can look at our normal rate. So normal x will be our radial stress. And if you're familiar, in the next video, we'll compare the stress results to hand calcs. But if you're familiar with pressurized cylinder stress, the radial stress is 0 on the outer radius. And then we have our y stress our axial stress is going to be pretty much 0. And you see here, it's kind of like it looks a little funny, but it's basically all 0. And then our normal stress in the z-axis is our hoop stress. And then we can look at our maximum principal and equivalent stress. Well, yeah, that's how you run a 2D axisymmetric analysis of a simple cylinder. And thanks for watching, and hopefully you guys learned something, and looking forward to making more videos for you guys, and thanks again.